OSIRIS-REx that landed, for example, on an asteroid, in this case, the asteroid Bennu, and it took a sample. See the asteroid in the upper right picture. And it took some samples, and it came back with those samples on the Earth. It landed in 2023 on the Earth, and on the lower right, you see some of those crumbs that were taken from the asteroid. And so we know where it came from. We analyzed it. We can compare it with asteroids. We can compare it with meteorites in our collections, so we know where they come from. Okay, next picture, please. Here we see the surface of our moon. And I've already shown it earlier, but here, closer up. And it shows craters, 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 big craters, small craters. If we could zoom in, you'd see craters that are only a few meters, some of them that maybe only a few centimeters across, because any object that falls from the sky there, because of the lack of atmosphere, will make a crater. How does that look at other planets? For example, next picture, please. Here we see some of the other surfaces of the so-called terrestrial or inner planets in our solar system. Those are rocky planets like our Earth. On the upper left, we see Mercury. This is a photo mosaic from spacecraft images put together, and it looks very much like the moon. Mercury, also like the moon, does not have an atmosphere. On the bottom, we see one crater in a radar image on the surface of our neighboring planet, Venus. Venus is almost as big as the Earth, but it has a very thick atmosphere, mostly made by carbon dioxide, and it has dense clouds. They prevent us from seeing optically the surface of Venus, but we can use radar, and there have been several spacecraft orbiting Venus, and what they showed with the radar images, lots of craters, and here is one of them, and it shows not only the crater itself, it shows also material that was thrown out of the crater because of the dense atmosphere. It doesn't fly very far, but you can see this whitish material, which is a false color basically, because of the radar image, is material that used to be in the crater and was thrown outside. On the upper right, we see Mars, the red planet, and again, many, many, many impact craters. Mars does have an atmosphere, but it is relatively thin compared to the Earth atmosphere. It is less than 1/100th of the thickness of the Earth atmosphere. So many, many meteorites come through. Also, Mars is smaller than the Earth, so geological processes mostly stopped some time ago. And again, lots of impact craters are preserved on the surface of Mars. Next picture, please. And that shows asteroids. Now, if we go out in the solar system, we know we have the inner planets, Mercury, Venus, Earth, and Mars. And then we have the outer planets, which are gas giants, Jupiter, Saturn, Uranus, and Neptune. In between Mars and Jupiter, we have the asteroids. Thousands and thousands, actually millions and millions of small bodies. Some of them are a few hundred kilometers across. Most of them are just a few kilometers across, or even a few hundred meters across. And here we have some examples of spacecraft images of some asteroids. And what we see is lots of craters, even on the surfaces of these asteroids, which means they're actually colliding with each other all the time as well, and they leave craters behind. And those are the objects, some of the smaller ones, that will eventually or can get into the inner solar system and hit Mars, our moon, our Earth, Mercury, Venus, and whatever else is around. And what you see here is one of them is relatively large. It's over 100 kilometers across. It's the biggest one. Some others are smaller, just a few kilometers across, but all have irregular shapes and lots of craters. So, next picture, please. If we go in the outer solar system, I've just mentioned that the planets are gas planets. So they have dense atmosphere. Of course, they don't have a solid surface, but they have moons. And here we see some pictures of some of the moons of the outer planets. Europa, for example, is a moon of Jupiter. Mimas, Titan, and Phoebe are moons of Saturn. And what we see here is round objects, craters. Europa, the moon of Jupiter, has an icy surface. Even on that icy surface, craters form. Mimas, that moon of Saturn on the bottom here, has a huge crater. It looks like the eye of a cyclops there. The moon is about 500 kilometers across. That crater is over 100 kilometers across. So it's huge. And again, all solid surface objects in the solar system are covered by meteorite craters, by impact craters. Okay, where does that leave the Earth? Next picture, please. Well, on Earth, we have lots of craters. Say craters, craters everywhere. And when you see these 9 craters here, I have to disappoint you. Only one of them is actually a meteorite crater. The others are mostly naturally formed craters that form by different geological processes on the surface of the Earth. Now, that is different from the moon or from Mars, for example, even though, of course, you might guess already, some of those craters have formed by volcanic processes. Next picture, here we see actually some names. Some of them are Mars, which have to do somewhat with volcanic processes. Others are volcanic craters. The one on the bottom in the middle is actually a blowout crater where methane has been escaping from the surface and it exploded and it makes a crater. So you have lots of different natural processes on Earth that can make craters. We have also some unnatural processes like the one in the right side on the center that is Sedan, and about more than half-kilometer diameter nuclear explosion crater. And that is one that looks very, very similar to a meteorite crater, which is the one on the upper left. Next picture, please. Here we see now that crater, which is fittingly called Meteor Crater, which is in Arizona in the United States, has a diameter of about 1.2 kilometers. It is also called Barringer Crater after the person who at the beginning of the 20th century for the first time figured out that this was made by meteorite impact. Now, how was that done? In fact, already in the 1800s, small pieces of iron meteorites were found around that crater, which of course at that time was not called Meteor Crater yet because people didn't know it had anything to do with meteorites. It was called Coon Butte, which are these cute animals that sit out there in the desert and they sun themselves on those rocks. And then only at the beginning of the 20th century, and I don't have time to go through the details here, was it figured out that in fact those iron meteorites, the name, by the way, of those iron meteorites is Canyon Diablo, and in the back right side, in the right upper corner of this photograph, of this aerial photograph, you see a little canyon. That is the Canyon Diablo, after which these meteorites were named. And these iron meteorite pieces that are maybe some meters maximum across actually are the remnant of a large body that later was found out to only have been approximately maybe 50 or 60 meters across that made that big, over 1 kilometer diameter meteorite crater. So this was something at a time at the beginning of the 20th century when many astronomers were still thinking that the craters on the moon were formed by volcanoes. because that is the experience they had from the Earth. Many craters on the Earth formed by volcanoes. Well, not on the moon, but they didn't know that yet. And so there was a lot of research going on, and it took many, many decades still. And the question was really only settled in the late 1960s when spacecraft explored the moon and the first lunar landings happened and samples were brought back from the moon, that it was realized that really all these craters are impact craters. By that time, in the 1960s, only a handful of craters, a few, 10 maybe, were identified on Earth as being of impact origin, because there was just nobody had observed an impact. And so it was something they didn't know about, people didn't know about. Volcanoes, everybody saw volcanic eruptions blowing up almost all the time over human history, but impacts, not so much. So it took a while before people and researchers were figuring out that yes, on Earth too, there are impact craters. And that started in the 1960s, really only. Next picture, that shows us a few other impact craters that we figured out later, even in the 1980s and 1990s only, so geologically, very recently, that these were formed by meteorite impact. Now, they didn't form that recent, but we humans, we researchers, we figured out only maybe 20, 30, 40 years ago that these craters were formed by meteorite impact. The one in the upper left, Namibia, Rotterdam crater, 2.5 kilometers in diameter. It's almost covered by desert sand. It's only 3.5 million years old. The one on the upper right is 1 million years older. So again, it's already disappearing. The one on the bottom is particularly interesting because it has the same diameter as meteor crater that we just saw in the previous image. But if you look, it is not as obvious. The crater rim is not as sharp. The crater is not as deep. And what's the difference? And also, rocks on the surface didn't show any evidence that it was formed by impact. No meteorites were found there at the surface. So what's the difference here? That crater in Arizona that we saw in the previous image is about 50,000 years old. This one here on the bottom is 250,000 years old. Geologically, that is nothing, but the crater rim is already eroded. The crater interior is already filled with younger rocks, with sediments, and we needed to drill down over 100 meters to find the rocks that actually had evidence that this is an impact crater. So that tells you something about that it's not so easy maybe to recognize impact craters on Earth. Next picture, please. Now here we have a crater in India, Lonar. This is one of the few craters that is formed on Earth in basaltic rocks. Again, on the surface, you'll have a very hard time identifying anything that really tells you its impact. Actually, it took a long time before we even figured out how old this one was. Now we know it's 500,000 years old. So again, geologically, relatively young. Next picture, please. This one shows a crater in Australia. And you see there's this circular chain of rocks in the center. And on the bottom, I wrote down saying that it's 22 kilometers in diameter. And you think this is that main ridge of rocks that you see here. No, it's not. In fact, if you look carefully, you see kind of a circular outline going around further on the outside. That was the original crater outline, the 22 kilometers. What we see here in the center is actually the so-called central uplift that used to be below the crater floor. That crater here is over 140 million years old. So a lot of the rocks have been weathered away and eroded away, and it makes it difficult to see that it's an impact crater. It's a crater at all, in fact. Next picture.